In the previous video, we rewrite the defined integral in right Riemann summation. Now we will rewrite a defined integral as a left Riemann summation. So again, we have the integral from a to b of a function f of x delta x is the same as, well, this is the limit as n approaches infinity. This is not the important part right now of the summation. From a left Riemann sum is from I equals 0 to n minus 1 of f of x sub I delta x. Now, what is x sub I? X sub I is just, look, we have a curve, whatever, and we want the area under the curve from A to B. From A to B. The rectangles are for left Riemann summation are these rectangles, like this. Remember, in a decreasing function, the left Riemann sum is overestimated. Now, the x sub I is this one, these left endpoints. This will be x sub 1, this will be x sub 2, this will be x sub 3, and this will be, this will be x sub 0, x sub 1, x sub 2, and x sub 3, because I divided in 4 intervals. We are in the left endpoint, so we have 4 summations, but we are beginning from x equals 0 because it is from the left endpoint. The x sub 1 is this one, and we begin from x equals 1 when we are doing right Riemann summation, but we begin from x equals 0 when we are doing left Riemann summation. Alright, so x sub I is x sub 1 is equal to a. X sub 2 is equal to a plus delta x. Sorry, this is x sub 0 is a, x sub 1 is a plus delta x, x sub 2 is a plus 2 delta x. So x sub I is, if I is 0, we can put it as a plus I delta x, because when I is equal to 0, we have x sub 0 is a. When I is equal to 1, x sub 1 will be a plus delta x. When I is equal to 2, we will have x sub 2 equals a plus 2 delta x. Alright, so this is x sub I. Now, we have the summation from I equals 0 to n minus 1 of f of x sub I, so a plus I times delta x times delta x. This is how we transformed a defined integral to left Riemann summation notation. Now, in this example, we have cosine. We go from pi to pi. So the left Riemann sum approximation would be the summation from I equals 0 to n minus 1, because I'm not saying how many rectangles we are getting. This would be our f of a plus I dx. So f of, what's a? From where are we beginning? Our a is pi plus I. Now, what's delta x? Delta x is the width of each rectangle. The width of each rectangle is b minus a divided by how many rectangles we have. So, in this case, we have 2 pi minus pi divided by n. So, delta x is pi over n. So, times pi over n. Delta x is again pi over n. So this is how we write this defined integral in left Riemann summation notation. Now, what happens if we write this as a left Riemann summation notation, but from the non-traditional way? That is, this is equal to the limit as n approaches infinity. That here we don't care because we are not taking infinitely rectangles, but the important thing is summation from I equals 1 to n of f of x sub I minus 1 delta x. So that is, we are beginning from I equals 1. So when I is equal to 1, that is our first term. Here the first term is I equals 1. In the previous one, our first term, this is first term, was I equals 0. So here, when I is equal to 1, we yet want x sub 0 equals a. When I is equal to 2, x sub 1 needs to be a plus delta x. When I is equal to 3, x sub 2 is equal to a plus delta x. And look here that this is x sub I minus 1. I is 1, x is 1 minus 1, x sub 0. I is 2, here is x sub 1, here is x sub 2 minus 1, etc. So this is x sub I minus 1. Now, this was x sub I when I begins from 1. Here, now our x sub I will be, when I is equal to 1, x of 0 is a. So we have a plus, here instead of having delta x times I, we would have delta x times I minus 1. So when I is 1, we have 1 minus 1, 0. X of 0 is equal to a. When I is 2, we have x sub, remember, 2 minus 1, x sub 1 will be equal to a plus delta x times 2 minus 1, 1 will be x of 1 is a plus delta x. That is exactly what we have here. So now our x sub I is not a plus I delta x, is a plus delta x times I minus 1. And so our f of x sub I is equal to f of a plus delta x of I minus 1. And so the summation notation is this sum from a equals 1 to n of f of a plus delta x times I minus 1 times delta x. Now, putting this in our sample, we have the summation from I equals 1 to n of what's f? F is cosine. Oh, sorry, here I forgot also to put it as cosine. This is summation from I equals 0 to n minus 1 of cosine of pi plus I pi over n times pi over n. And this is summation from I equals 1 to n of cosine of a, that is pi, plus delta x is pi over n times I minus 1 pi over n. Pi over n. So this can be written as this as from left Riemann sum as the summation from I equals 1 to n of cosine pi plus pi over n of I minus 1 pi over n, or the summation from I equals 0 to n equals to n minus 1 of cosine of pi plus I pi over n all times pi over n. So we have two ways of write the left Riemann summation, the same as two ways of write the right Riemann summation. We did this with right Riemann summation in the previous video, and if you compare, the right Riemann summation was from I equals 1 to n of cosine of pi plus I pi over n delta x, and in the other way is from I equals 0 to n minus 1 of cosine of pi plus pi over n times I plus 1 delta x. Delta x is pi over n. So comparing, remember that I told you that the traditional way was when we just have here I. So when we have f of x sub I, or if you want to see it, f of just a plus I dx. Yes, here we have a plus I dx. This is this one. For the right Riemann summation, remember that we have the summation from I equals 0 to n of f of I plus a plus I delta x times delta x, or the summation from from I equals 0 to n minus 1 of f of a plus delta x times I plus 1 delta x. So now you can compare them. We have four ways of writing this defined integral, two right Riemann sums and two left Riemann sums. Look that this one looks very similar to this one. We have summation of cosine of pi plus I pi over n times, pi over n. But here the summation goes from I equals 0 to n minus 1. And here the summation goes from I equals 1 to n. And this is the traditional way for each one. The traditional way is from the left when we begin from I equals 0 to n minus 1, and the right is when we begin from I equals 1 to n. I think this is getting too long, so we will continue in the next video.